This is lesson 3.1, using graphs and tables to solve linear systems. We are going to today determine if an ordered pair is a solution to a system of equations and solve systems of equations by using graphs and tables. All right, so our topic is systems of linear equations. So a system of linear equations written in the same variables. The solution of a system of equations is the set of all points that satisfy each equation. So first, we're going to look at how we might determine if an ordered pair or a point is a solution for that system of equations. So the point 4, 3 represents an x and a y value. And what we're going to do with that x and y value is plug it into our equations and see if, when we plug those numbers in, if the statements are true, if they are in fact both equal to 10 and then 9. So if x is 4 in this first equation, we're going to do 4 plus 2y, y is 3, so 2 times 3 is 6, equals 10. Well, 4 plus 6 is 10. And then look and see, is 10 equal to 10? Yes, it is. So it works out in that equation. Then we're going to try in the next equation. So x is 4, so we do 3 times 4, which is 12, minus y, which is 3, equals 9. 12 minus 3 is 9. All right, does 9 equal 9? Yes, that is true. So what we can say then is, yes, 4, 3 is a solution to that system of equations. Now we do the same with number 2. The 0.53, that gives us our x and our y value, and we plug it in to our first equation. So 6 times 5 minus 7 times 3 equals 1. That's 30 minus 21. Does that equal 1? 30 minus 21 is 9. 9 does not equal 1. So the fact that 5, 3 does not fit into this equation means that it is not going to be a solution for the system. So once you find one that doesn't work, that means it doesn't work at all. So no, 5, 3 is not a solution to this system. All right, next we're going to look and see how we might use a table and or a graph. So nice thing about linear equations is we've just gone through how to graph all of those. So what we're going to do is we're going to graph these, and then I can show you in the table too what that looks like, but we're just going to start by graphing them right away. So if x plus y equals 5, I like to graph from the slope-intercept form, especially in a case like this, where I can easily solve for y. If I subtract x from both sides, I get y equals negative x plus 5. Now that negative is like a negative 1, so if I graph this equation, I would do the y-intercept at 5, and my slope is negative 1. So down 1 and right 1 from there. And just kind of keep doing that. Down 1, right 1, down 1, right 1, because it has a slope of negative 1. And then connect those dots. Okay. Next, I'm going to graph y equals 1/2 x plus 2. My y-intercept for that one is 2. And then from there, I'm going to follow the slope of rise over run, 1 over 2. Up 1, right 2. Up 1, right 2. And then draw on my line. Now, the solution to our system is where those two lines intersect. Those two lines intersect here at that point. So the solution is whatever that coordinate point is. That point is at 2, 3. So our solution here is going to be 2, 3. Now, if you prefer, you can use a table. It just might take a little bit more. So what you basically want to do is put your values into your equation and then solve for y? Well, since we already solved for y over here, y is negative x plus 5, or 5 minus x might be a little easier to think of. What you're going to do then is just do 5 minus each of your x values to get the y value. So here, 5 minus negative 1 is 6. 5 minus 0 is 5. 5 minus 1 is 4. And 5 minus 1, 2, excuse me, is 3. All right, then over here, we're going to take half of x and add 2. So half of negative 1 plus 2. So that's negative 1 half plus 2, 3 halves. 0, half of 0 is 0 plus 2 is 2. Half of 1 is 1 half plus 2 is 2 and a half, which is 5 halves. And then half of 2 is 1 plus 2 is 3. And then in these tables, you can see, oh, this table has the 0.23 and this table has the 0.23. So that is our solution, 2, 3. So from here on out, we are going to graph using the slope-intercept form. Right, so for this first one, number 4, negative 4x plus y equals 1. So if I solve for y, we would add 4x to both sides. So we get y equals positive 4x plus 1. That gives us a y-intercept of 1 and a slope of 4. 1, 2, 3, 4 up, 1 to the right. And then if we connect those dots as best as we can, there we go. We should get that line. Then we're going to graph y equals negative 3. Hopefully you recognize this. Y is equal to negative 3. Negative 3 is down here, and that is going to be a horizontal line. Anything that's just y equals a constant is a horizontal line. Now remember, the solution is where your lines intersect. These intersect right here at negative 1, negative 3. So our solution is negative 1, negative 3. All right, number 5. You can see here, so in this one, in number 5, you can see if we use y or x and y intercepts, sometimes you end up with these fractions. So from here on forward, I'm probably just going to do these in slope intercept form. If you'd like to pause and try these on your own first and then check your answers to see, you can certainly do that. Otherwise, I'm just going to go through these and you can continue to follow along if you need the extra help with graphing. So for number 5, we're going to start by dividing everything by 4 here to get y equals 3x plus 2. All right, to graph that, our y-intercept is 2 and our slope is 3. So up 1, 2, 3, right 1. And then that point would be down there. All right, something like that. And then our next equation, I'm going to solve for y here. So we get negative 2y equals 10 minus 6x. Divide everything by negative 2. So we get y equals negative 5 plus 3x. So our y-intercept is negative 5, and our slope is a positive 3x. So we go up 1, 2, 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. Just give myself enough points to connect a nice line here. All right, so what do you notice with this one? We said a solution has to be when our lines intersect. These two lines don't intersect. Why don't these two lines intersect? Well, what do you know? They have the same slope. Remember, same slope means parallel lines. So parallel lines, remember, never touch. So if that's the case, if you have the same slope, you have parallel lines. So that means there is no solution. And that might happen sometimes. And graphing kind of helps show you that. All right, number 6. So number 6, oh, the first equation here is already in slope-intercept form. Y-intercept of 2, slope of 1/4, up 1 over 1, 2, 3, 4. There we go. Oops, that would have been a terrible line. There we go. All right, now this one, if we solve for y, we get 8y. So let's do that in blue since it's our other equation. There we go. 8y equals 16 plus 2x. You have to add the 2x. Divide everything by 8. You get y equals 2 plus 2 over 8 is 1/4. Okay, well, what do you already notice here? They both have a slope of 1/4 again. So if I graph this, I should see that they're parallel and we will have no solution. Oh, but wait, this time they even have the same y-intercept. They both have a y-intercept of 2 and a slope of 1/4. So that means every point is going to be the same. When that's the case, if you get the same equation, that means we have something called infinitely many solutions. The lines are the same, so that's infinite solutions. Okay, and we say infinite because this line is made up of an infinite number of points, right? Any x and y value that fits into that line is going to be a solution. So there's infinite solutions for that one. All right, number 7. Now, how can we apply systems of equations? What might be like a problem that would need to be solved using systems of equations? Well, if you have like two different things going on, but you're talking about a similar idea, right? And you're trying to compare things. So here we're talking about two different membership fees for music memberships. So we have Super Music, and they charge a $20 membership fee and $5 per month to use their music app. I guess kind of like the difference between what like Spotify and what's some other one, SoundCloud. Anyway, a similar music app, Mega Hits. So that's our other one. We'll do that one a different color. Mega Hits charges a $5 membership fee, but $10 per month. So you can already see here they kind of have different things going on, right? One of them charges more up front, but then the other one charges more per month. So what we're trying to find out is when will the cost be the same for both memberships? And what is that cost? So first let's see what we're comparing here, right? We're comparing number of months, right? Number of months being a part of that membership. So we are comparing months to cost. Okay, months to cost of that membership. All right. So let's write equations for each of these, and then we should be able to compare the two. So for Super Music, the cost for Super Music is going to be $20 right away, and then $5 per month, X. Whereas Mega Hits, the cost of your membership is going to be $5 plus $10 per month, X. All right, so we need to figure out when those are going to be the same. Let's graph them. All right, so I'll graph Mega Hits first here since I already have the blue out. So we start at 5. So 5. And then it's going up $10 per month. So 5, 10. So up $10 over 1 month. Up $10 over 1 month. Up $10 over 1 month. And up $10 and over 1 month. All right, so there's our line to represent cost for megahits. All right, and then for super music, well, they start at $20, but now they're only going up $5 per month. So $5 for 1 month, $5 for 1 month, $5 1 month, up $5 over 1 month, like that. And you can see that those points overlapped right here, right? At 3 months and $35. So now we have to look at what our question is asking. When will the cost be the same for both memberships? So when is our key word here. So when we're looking at our number of months. So we're looking at our X. Well, that's happening at 3 months, according to our graph. And what is that cost? So now we're going to be looking at the y-axis. So the y value of that point was 35, and that's dollars. Okay, so at 3 months, it costs $35, and that's where they are the same. So you can see here, if you just wanted to be a member for 3 months, you would probably want to be a part of mega hits, right? Because it's less there. Whereas if you're planning to be a long-term member, you're probably going to want to choose super music, because after a while they end up being less. So you can kind of look and see those lines intersect, and whichever one is above the other one is going to be more expensive. So that's another thing they can help you find out. So that's just our intro to systems of equations, being able to solve them by graphing. So it gives you more practice graphing linear equations. And then remember, where they intersect is the solution. And then remember, if you have parallel lines or a line that's the same, what that means. No solution and infinite solutions. All right, so go ahead and do some practice and make sure you ask your teacher if you need any help.